Look up at the night sky. What do you see? A tapestry of stars, distant galaxies, maybe the faint glow of a planet. But here's the unsettling truth. Not everything out there is what it seems. The universe is a master illusionist, playing tricks on even the most brilliant minds. Those shimmering points of light, some are cosmic mirages, bending around invisible forces in space. That galaxy you swear is real, it might be a ghostly echo of something far older, warped by gravity into a shape that defies logic. These aren't just quirks of astronomy, they're clues to the universe's deepest secrets, hidden in plain sight. Think about the last time you were fooled by an optical illusion, a drawing that seemed to move, or shadows that twisted reality. Now imagine that on a galactic scale, where entire stars vanish into thin air, and black holes act like cosmic projectors, casting shadows light years across. These illusions aren't just fascinating, they're rewriting the rules of physics. Take Einstein's cross, for example. A single quasar split into 4 identical images by the gravity of an entire galaxy. Or the phantom stars that vanish when you try to pin them down, leaving astronomers scratching their heads. These aren't mistakes, they're the universe revealing its hidden machinery, one mind-bending trick at a time. So why should you care? Because every time we unravel one of these cosmic deceptions, we peel back another layer of reality. What if the Big Bang itself was an illusion, or dark matter is just space's way of fooling our instruments? This journey isn't just about spotting tricks, it's about learning to see beyond them, to the truths that shape everything from the birth of stars to the fate of the cosmos. Over the next 25 revelations, you'll witness space's greatest sleight of hand, from galaxies that shouldn't exist to light that lies about its own age. By the end, you won't just question what you see, you'll wonder if anything out there is as it appears. Ready to have your reality twisted? Let's dive in. Imagine staring at a pair of galaxies so perfectly matched they could be siblings, same spiral arms, same glowing core, even the same faint halo of stars. But here's the twist, one of them isn't real. It's a cosmic doppelganger, a trick of light bent by the gravitational pull of an invisible giant lurking in the void between them. This is the illusion of galactic twins, where spacetime itself becomes a funhouse mirror, warping reality so convincingly even telescopes get fooled. Einstein saw this coming. His theory of general relativity predicted that massive objects like galaxies or black holes don't just sit in space, they twist it, creating invisible curves that redirect light like a prism. When a distant quasar's light passes through this warped spacetime, it can split into multiple images, like a candle's flame reflected in a shattered mirror. The Hubble Space Telescope spotted one of the most famous examples, the twin quasar, where a single blazing quasar appears duplicated in the sky, separated by a gap of space that doesn't actually exist. The real marvel, the twin, is a ghost, a reflection delayed by years, offering astronomers a glimpse into the quasar's past, but the illusion goes deeper. These cosmic mirages aren't just curiosities, they're proof of dark matter's grip on the universe. The amount of bending we see can't be explained by visible matter alone. There's something else out there, invisible and immense, flexing space-time like putty. Every false twin is a breadcrumb trail leading to the hidden scaffolding of the cosmos. So next time you see a pair of matching galaxies in a telescope image, ask yourself, are you looking at 2 objects or just one, stretched and mirrored across the universe's invisible curves? The answer might rewrite what we know about gravity, light, and the very fabric of reality. A star explodes in a cataclysmic burst of light, Then, years later, it seems to explode again in the exact same way. This isn't science fiction. It's the bizarre reality of phantom supernovas, where dying stars perform encores across the cosmos thanks to gravity's sleight of hand. In 2014, astronomers spotted a supernova flaring to life not once, but 4 separate times, arranged in a perfect cross around a massive galaxy cluster. Each brilliant point wasn't a new explosion, just the same doomed star's light taking different cosmic detours around the cluster's immense gravity, like beams bouncing through a hall of mirrors. The cluster acted like a colossal lens, bending spacetime so dramatically that light from the supernova split into multiple paths. Some photons raced straight toward us, while others got diverted on scenic routes, looping around the cluster's unseen dark matter before finally reaching Earth years later. The result, a single stellar death played on repeat, with each reappearance offering a time-delayed snapshot of the explosion's aftermath. It's as if the universe hit pause, then rewind, letting scientists study the same supernova at different stages of its decay. But here's where it gets even stranger. These phantom explosions aren't just cosmic reruns, they're X-rays into the invisible. By tracking how the light warps, astronomers can map the hidden distribution of dark matter within the galaxy cluster, weighing its gravitational pull like a cosmic scale. The 4-image cross, nicknamed Supernova Refstal, revealed pockets of mysterious matter no telescope could see directly. Could these repeating supernovas challenge what we know about stellar life cycles? Normally, when a star dies, it's gone for good. But if gravity can stitch its final moments into a looping highlight reel, it raises a tantalizing question. How many other, one-time cosmic events are secretly replaying across the universe, just waiting for us to stumble upon their delayed encore? Every phantom supernova isn't just an illusion, it's a time capsule, a gravity-powered echo reminding us that even in death, stars have a few more tricks to show us. One of the most striking cosmic illusions isn't about something appearing, it's about something vanishing right before our eyes. Take the Red Rectangle Nebula, a celestial masterpiece that glowed for decades with its distinctive geometric shape and crimson hues. Then, in 2022, it began to fade, not slowly like a dimming light bulb, but dramatically, as if someone flipped a switch. Astronomers scrambled to understand, was this cosmic artwork being erased by dust, or was it collapsing in on itself in some unprecedented way? The Red Rectangle wasn't just any nebula. Its perfect symmetry made it a textbook example of how dying stars sculpt their surroundings. At its heart, a pair of aging stars pumped out cascades of gas and dust, painting the cosmos with their final breaths. For years, telescopes captured its vibrant glow until suddenly they didn't. The leading theory, a thick shroud of dust expelled by one of the central stars, may have drifted into our line of sight, acting like a cosmic curtain. But here's the catch: dust doesn't usually move that fast. If it wasn't dust, then the nebula itself might be undergoing a transformation so rapid, it challenges everything we know about stellar evolution. This vanishing act forces us to confront a humbling truth. The universe doesn't perform on our timetable. Nebulae, which we often think of as slow-changing relics, might have flickering lifespans, with phases of brilliance and obscurity playing out in cosmic quicktime. The Red Rectangle's disappearance isn't just a puzzle, it's a warning. How many other celestial wonders might fade before we fully understand them? And what if some of the empty patches of space we see today are actually the graveyards of nebulae that vanished before our telescopes were powerful enough to catch them? The eerie part: this isn't the first time astronomy's playbook has been upended by a disappearing act. In the 1900s, a massive star in the constellation Orion simply winked out of existence, leaving no supernova, no black hole, just questions. If entire nebulae can vanish without warning, it makes you wonder, what else in the night sky is an illusion, here today and gone before we even grasp its significance? Every time one of these cosmic mirages fades, it's not just a loss. It's a clue hinting at processes so fleeting, so mysterious, they defy our best instruments and theories. The universe isn't just showing us its secrets, it's teasing us with glimpses, then pulling them away before we can look too closely. Deep in the cosmic static, there are bursts of radio waves so powerful they outshine entire galaxies for just a fraction of a second. These fast radio bursts, or FRBs, flash like cosmic strobe lights, vanishing before astronomers can blink. But the real mystery isn't their speed, it's their eerie precision. Some repeat in patterns so regular they could be mistaken for signals from an intelligence beyond our own. Take FRB 180916. Every 16.35 days, like clockwork, it fires off a series of millisecond pulses, then falls silent. The rhythm is so exact, so unnatural, it sent shockwaves through the scientific community. Could this be the signature of alien technology? Nature, it turns out, is a master mimic. After years of speculation, researchers traced some repeating bursts to hyper-magnetized neutron stars called magnetars. These collapsed stellar cores spin with such ferocious energy, their magnetic fields could strip the data from every credit card on Earth from halfway across the galaxy. When their crusts crack under the strain, they unleash bursts of radiation, including those tantalizing radio pulses. The universe, it seems, has its own Morse code. But here's the twist, not all FRBs fit this explanation. Some come from regions of space too empty to host magnetars, or arrive with energy levels that defy physics. One burst detected in 2019 traveled 7 billion light-years only to repeat months later, long after any known stellar object should have burned out. Even stranger, a handful arrive with a bizarre double pulse, as if something or someone is hitting cosmic rewind. The unsettling truth, we might be witnessing two entirely different phenomena. Some bursts are clearly natural, the death throes of extreme stars. Others, their origins remain wide open. Every time we think we've pinned them down, they defy us again. So next time you hear about a mysterious radio pulse from deep space, ask yourself, are we decoding the universe's hidden language, or eavesdropping on something far more extraordinary? The answer could rewrite not just astronomy, but our place in the cosmos. Picture a galaxy racing away from us at unimaginable speed, faster, in fact, than light itself should allow. According to Einstein, nothing in the universe can outpace light. Yet when astronomers peer deep into space, they find distant galaxies doing exactly that, their light stretched into redder, dimmer ghosts as they seemingly flee from us. This isn't a cosmic speed limit being broken, it's space itself playing the ultimate trick, stretching like taffy under the invisible hand of dark energy. The discovery of this illusion, what scientists call the accelerating expansion of the universe, earned a Nobel Prize in 2011. But here's the twist, those galaxies aren't actually moving through space at all. Instead, the fabric between them is swelling, carrying them apart like raisins in rising dough. The farther away a galaxy is, the more space there is to stretch, creating the illusion of breakneck acceleration. It's not the galaxies speeding up, it's the stage beneath them growing larger, warping our perception of reality on the grandest scale. Dark energy, the mysterious force behind this expansion, makes up 68% of the universe, yet we've never seen it, never touched it, never detected it directly. All we know is its effect, space stretching faster and faster, as if the cosmos is determined to fling everything apart. Some theories suggest dark energy might be a property of empty space itself, growing stronger as the universe expands. Others propose it's evidence of hidden dimensions or even flaws in Einstein's gravity equations. What makes this illusion so unsettling is its implications for the far future. If space keeps stretching at this rate, distant galaxies will eventually vanish from view entirely, their light stretched beyond detection. Future civilizations might gaze into a night sky almost empty of galaxies, with no clue that a universe of wonders once lay beyond. This phantom acceleration isn't just bending light, it's rewriting cosmic history, forcing us to question whether the expansion we see is real or just another layer in the universe's grand deception. So when you hear that the universe is expanding, remember, the truth might be even stranger. We're not just observers of this cosmic drama, we're caught in the middle of it, watching as the very rules of reality stretch and twist before our eyes. The question isn't just whether galaxies are moving, it's whether space itself is conspiring to make us see things that aren't quite what they seem. In 2018, something bizarre circled our planet, a mysterious object designated 2018 VP1. At first, astronomers dismissed it as just another piece of space debris, another fragment of humanity's orbital clutter, but then it started behaving strangely. Unlike typical satellites or rocket remnants, this interloper followed an oddly tilted path, looping around Earth in a way that defied easy classification. Then, just as suddenly as it appeared, it vanished from telescopes entirely. No explosions, no fiery re-entry, just gone like a cosmic ghost. It left behind nothing but questions. Theories erupted. Could this have been a stealthy asteroid, a rare mini-moon temporarily captured by Earth's gravity? Or was it something we put up there decades ago, a forgotten piece of a Cold War-era rocket, tumbling back into view like an archaeological relic? The truth is, we might never know. Space is full of such phantoms, objects that flicker into our awareness only to disappear before we can pin them down. What makes this particular vanishing act so unsettling is how it exposes the gaps in our cosmic surveillance. We track thousands of satellites and asteroids, yet something the size of a small car can slip past our best detectors, orbit our world, and vanish without a trace. This isn't just about lost space junk, it's about the blurred line between the natural and the artificial. In an era where human-made objects outnumber asteroids in near-Earth space, how do we tell what's a rock and what's a relic? Some defunct satellites, bleached by decades of sunlight, look eerily like asteroids. Meanwhile, certain space rocks have surfaces so reflective they mimic polished metal. The ghost satellite of 2018 might have been either or neither. The deeper mystery, objects like this might be more common than we think. Astronomers estimate dozens of temporary mini-moons could be orbiting Earth at any given time, most too faint or fleeting to spot. Some might even be fragments of the moon itself, knocked loose by ancient impacts and caught in gravitational limbo. Others could be artifacts of our own space age, drifting back into view like messages in a bottle. So the next time you hear about an unidentified object circling Earth, remember, the cosmos doesn't sort itself into neat categories. Between the natural and the man-made, between the ancient and the modern, there's a shadowy middle ground where reality itself seems to flicker. And in that uncertainty lies a humbling truth sometimes. Even the things orbiting right over our heads can remain as mysterious as the farthest reaches of the universe. In the heart of Galaxy M82, astronomers thought they'd struck gold, a textbook black hole, its gravitational pull so fierce not even light could escape. Then the signal started acting strange. Instead of the steady, inescapable silence of a true singularity, this object flickered. it emitted bursts of X-rays in rhythmic pulses, like a cosmic metronome keeping time across the universe. The culprit, not a black hole at all, but a neutron star with an identity crisis. Its magnetic field so intensely twisted it created the perfect illusion of an event horizon. Neutron stars are already extreme, city-sized remnants of dead suns, so dense a sugar cube-sized chunk would weigh as much as a mountain. But this one, officially named X2 in M82, took things further. Its magnetic field, trillions of times stronger than Earth's, warped surrounding space so severely that it mimicked a black hole's light-trapping grip. Radiation struggling to escape created patterns nearly identical to those expected from a true singularity's edge. For years, telescopes were fooled, their data whispering tales of a black hole where none existed. The discovery sent shockwaves through astrophysics. If one neutron star could impersonate a black hole this convincingly, how many others are hiding in plain sight? Estimates suggest up to 10% of suspected black holes in nearby galaxies might actually be these magnetic doppelgangers. The implications are staggering. Every misclassified object could rewrite our understanding of stellar deaths. Black holes form when massive stars collapse past the neutron star stage, crossing a point of no return. But if some black holes are really ultra-magnetized neutron stars, it means certain stars might hit a cosmic pause button, teetering on the brink of singularity without ever tipping over. What makes this illusion so devious is how it exploits our tools. Astronomers often identify black holes indirectly by watching how they distort space and absorb light. A magnetic neutron star can fake both signatures with eerie precision. The only telltale signs, subtle pulsations or bursts of radiation, are easy to miss unless you're looking at exactly the right moment. It's like spotting a master forger's work. From a distance, the imitation is flawless. You need to catch the brushstrokes up close. This cosmic case of mistaken identity forces a humbling question. Are we even counting black holes correctly? Every new impostor found suggests the universe's roster of singularities might need a major revision. And lurking behind that uncertainty is an even bigger mystery. What flips the switch that lets some dying stars stop just short of becoming black holes, while others plunge into the abyss? The answer could rewrite the final chapter of stellar evolution, proving once again that in the cosmos, even the most extreme objects might not be what they seem. For centuries, skywatchers in dark desert regions have reported a strange, ethereal glow rising from the horizon just before dawn, a faint pyramid of light stretching upward through the constellations. Known as the zodiacal light, this phenomenon was neatly explained as sunlight scattering off countless tiny asteroids between Mars and Jupiter. But recent discoveries have torn that explanation apart. The real source, dust from Mars itself, catapulted into space by the planet's monstrous global storms. Here's how the illusion works. Every few years, Mars erupts in continent-sized dust storms so violent they lift particles high above the planet's thin atmosphere. Some escape entirely, forming a shimmering interplanetary haze that follows the ecliptic, the same path the Sun and planets travel across our sky. From Earth, this creates the illusion of a celestial pathway glowing with reflected sunlight, as if the asteroid belt itself were lighting up. The deception held for so long because the dust particles resemble asteroid debris in size and composition. Only by analyzing the light's polarization, the way its waves align, did researchers spot the Martian fingerprint hidden in the glow. The implications are staggering. If something as local as zodiacal light can originate from another planet's weather, what other cosmic phenomena might be wearing disguises? Consider the auroras. Earth's northern lights were once thought unique until we spotted them on Jupiter, powered by volcanic moons rather than solar wind. Even meteor showers, long assumed to be comet debris, occasionally spit out particles with odd chemical signatures hinting at origins beyond our solar system. What makes the zodiacal light deception so profound is how it reframes our place in the cosmos. That soft glow isn't just asteroid dust, it's the breath of another world, a whisper of Martian tempests woven into Earth's night sky. It forces us to ask, when we look up, how much of what we see is truly ours, and how much is borrowed stardust drifting through the shared spaces between planets. The next time you spot that ghostly glow before sunrise, remember, you're not just seeing sunlight. You're witnessing the aftermath of a storm that raged 100 million miles away, painting our sky with the sands of another world. And if Mars can fool us this easily, what else in the night sky is quietly pretending to be something it's not? The universe loves a good costume party, and we're only just learning to spot the disguises. At the farthest edges of theoretical physics lies a concept so strange, it makes black holes seem ordinary cosmic strings. Imagine the universe as a vast fabric, not just bending under gravity's weight, but stitched together with invisible, thread-like flaws left over from the Big Bang. These hypothetical relics, thinner than an atom yet stretching across billions of light years, could be warping reality in ways that trick our telescopes into seeing double. The idea sprang from the chaotic aftermath of the universe's birth. As space-time cooled and expanded, theorists suggest it might have formed defects, cracks in cosmic ice, so to speak. Cosmic strings would be the sharpest of these flaws, infinitely long, unimaginably dense one-dimensional lines carrying the tension of the early universe. If they exist, their gravitational pull wouldn't just bend light, it would slice through space like a taut wire through foam, creating duplicate images of galaxies aligned with eerie precision. Picture a distant quasar split into identical twins, not by a galaxy's gravity, but by a string so thin we'd never see it directly. The illusion gets weirder. Unlike gravitational lenses, which smear and distort light, cosmic strings could produce mirror-perfect copies. In 2003, astronomers thought they'd spotted evidence, a pair of galaxies aligned so flawlessly, the odds of it happening naturally were astronomically low. Dubbed the CSL-1 candidate, it ignited a firestorm of debate. Was this a smoking gun for cosmic strings, or just a freak alignment? Follow-up observations proved inconclusive, leaving the mystery dangling like the strings themselves. But why does this matter? Because cosmic strings aren't just space's hidden stitches, they're potential time machines. Their extreme mass could twist space-time into closed loops, theoretically allowing particles to travel backward in time. Some models even suggest these strings might still be vibrating like guitar plucked at the dawn of time, humming gravitational waves we could one day detect. The most tantalizing part, strings could solve a cosmic coincidence. Why do some galaxy pairs align too perfectly for random chance? If strings are the culprit, they'd be the universe's ultimate puppeteers, arranging celestial objects like beads on an invisible wire. Until we find definitive proof, these threads remain the most elegant illusion of all, a theory so compelling, so rich with implications, that their very elusiveness makes them irresistible. After all, what's more deceptive than something that might not exist at all, yet could rewrite the rules of reality if it does? In 2018, astronomers spotted something extraordinary, a flicker of movement near a gas giant orbiting the star Kepler 1625. The data suggested a moon, not just any moon, but one the size of Neptune, dwarfing every natural satellite in our solar system. Excitement rippled through the scientific community. This could be the first confirmed exomoon, a landmark discovery. Then, like a cosmic magician's trick, it was gone. Follow-up observations found nothing. No moon, no debris, not even a trace. The Phantom Exomoon had vanished without explanation. Was it a glitch in the data? Possibly. Kepler's instruments are sensitive and false positives happen. But another theory is far more intriguing and violent. Imagine a moon orbiting too close to its planet, caught in a gravitational tug of war. Tidal forces stretch it like taffy, heating its core until it fractures. Over millennia, it's shredded into a ring of debris, some falling into the planet's atmosphere, the rest scattering into space. By the time we pointed our telescopes back, the demolition might have been complete, leaving only stardust where a world once orbited. This isn't just about a missing moon. It's about the fragility of celestial bodies in extreme environments. Jupiter's volcanic moon Io survives its constant tidal stretching because it's constantly reheated, but not all moons are so resilient. A gas giant's gravity can be a slow-motion shredder, especially around younger, hotter stars where orbits are chaotic. The Phantom Exomoon might have been a casualty of these forces, a brief, brilliant existence cut short by cosmic mechanics we're only beginning to understand. What makes this illusion so haunting is the timing. We might have glimpsed the Exomoon in its death throes, a snapshot of destruction that's incredibly rare to witness. It's like stumbling upon a building mid-collapse. You see it for a split second, then only the dust remains. If true, it suggests moons around distant worlds might come and go faster than we thought, their lifespans measured in millions, not billions of years. The search isn't over. Every time we think we've found an exomoon, we're reminded how tricky detection can be. Light curves dip, shadows shift, and sometimes the universe teases us with signatures that disappear before we can confirm them. But each phantom, each near discovery, teaches us something new about the limits of our tools, the violence of planetary systems, and the fleeting nature of cosmic companions. The next time we spot a blip in the data, we'll be wiser and ready to ask, is this the real thing or another ghost in the machine of the cosmos? Jupiter's poles were supposed to be orderly, mathematical perfection carved into swirling gas. When the first distant images showed a hexagon at Saturn's North Pole, scientists assumed Jupiter would follow suit, its storms locked into stable, symmetrical patterns. Then Juno arrived. The spacecraft's close-up shots revealed chaos, a tempest of cyclones jostling like drunken dancers, some big enough to swallow Earth whole, with no geometric harmony in sight. The polar vortex wasn't a serene celestial clockwork. It was a mosh pit of atmospheric fury, rewriting everything we thought we knew about gas giants. The illusion here runs deep. For decades, models of planetary weather relied on Earth's logic that rotation and fluid dynamics would create predictable systems. Jupiter shattered that arrogance. Its poles host 8 cyclones around a central storm at the north and 5 at the south, none of them neat polygons. Some spin clockwise, others counterclockwise, defying the Coriolis effect that organizes our own planet's hurricanes. Even more baffling, these storms refuse to merge, pinned in place by forces we still don't understand. It's as if Jupiter took our textbooks, shredded them, and tossed the pieces into its own winds. What makes this mirage so humbling is what it implies about other worlds. If Jupiter's poles fooled us, what else have we gotten wrong? Uranus and Neptune, with their tilted magnetic fields and diamond rain, might be hiding even weirder secrets. Even Earth isn't safe. Recent studies suggest polar vortices in our own atmosphere are growing more erratic, buckling under climate change in ways that mirror Jupiter's unpredictability. The universe seems to delight in taking our neat categories, order versus chaos, symmetry versus randomness, and blurring them beyond recognition, the real kicker. Juno's data hints that Jupiter's chaos might be skin deep. Beneath those raging storms, the planet's magnetic field is oddly symmetrical, as if the madness above is just a mask for something far more structured below. It's a cosmic reminder. First impressions, especially in astronomy, are often illusions. The closer we look, the more the universe reveals its true face, not as a machine following human rules, but as a living, shifting enigma, daring us to keep questioning. So the next time you see an artist's rendering of a distant exoplanet with tidy bands and perfect storms, remember Jupiter's lesson. Out there, beyond our assumptions, the cosmos is wilder, messier, and more inventive than we ever imagined. And the greatest illusion of all, thinking we've got it figured out. Imagine a world where mountains gleam like jewelry stores, where rivers of liquid diamond carve valleys into continents of pure crystal. That was the dream of 55 Cancri, a planet so rich in carbon. Early observations suggested it might be one massive gemstone orbiting a distant star. The headlines wrote themselves, "Diamond Planet Discovered." But like so many cosmic wonders, the truth turned out darker, hotter, and far more volatile. The illusion began with the planet's density. 55 Cancri orbits so close to its sun that a year lasts just 18 hours, baking its surface to thousands of degrees. Early models, seeing its carbon-heavy composition and high pressure, theorized those conditions could crush carbon into diamond. Telescopes even caught hints of reflective surfaces, as if sunlight was bouncing off vast crystalline plains. But when researchers looked closer, the glittering facade cracked. Instead of a diamond crust, they found a world drowning in lava, its carbon-rich atmosphere creating a cruel optical trick like gold leaf over a furnace. Here's the twist: that carbon isn't forming serene diamond caverns. It's trapped in a cycle of destruction. The planet's day side, permanently scorched by its star, reaches temperatures where diamonds wouldn't just melt, they'd boil. Any carbon that crystallizes on the cooler night side gets dragged back into molten currents, vaporized anew. The diamond planet might have diamond rain, but it falls into seas of fire, a glittering hellscape where precious stones are born only to burn. What makes this cosmic bait and switch so fascinating is how it mirrors our own biases. Humans see carbon, think diamonds. Nature sees carbon, thinks chaos. The same element that makes our engagement ring indestructible here becomes the fuel for endless volcanic fury. It's a reminder that the universe doesn't care about our fantasies of treasure. It follows physics, not poetry. Yet the story isn't over. Recent studies suggest pockets of diamond might still exist deep beneath the lava, trapped in a solid layer like frosting between cakes of magma. If so, 55 Cancri is both nightmare and jewel box, its true nature hidden beneath layers of illusion. The next time you hear about a diamond planet, remember, the cosmos loves a good costume. Behind every beautiful hypothesis, there might just be a volcano in disguise. For decades, astronomers painted the Milky Way as a cosmic predator, a voracious giant shredding smaller galaxies and absorbing their stars in an endless feast. The evidence seemed clear. Streams of stars torn from dwarf galaxies encircled our own, like crumbs left behind after a meal. Then came the Gaia Space Telescope, mapping stellar motions with unprecedented precision and revealing a shocking twist. Those crumbs weren't leftovers at all. The so-called victim, a dwarf galaxy called Sagittarius, wasn't being devoured. It was performing a gravitational slingshot, whipping around the Milky Way's edges with enough speed to escape intact. The illusion here cuts to the heart of galactic evolution. When we see stretched out trails of stars, we assume violence, a smaller galaxy ripped apart by a larger one's gravity. But Sagittarius tells a different story. Its stars aren't being pulled inward, they're being flung outward, stretched into filaments by near misses that look like consumption from afar. It's the difference between watching a comet disintegrate as it plunges into the sun versus seeing one whip around and sail away, forever altered but still whole. This raises an unsettling question. How many other cannibal galaxies are just messy diners, leaving stellar debris strewn about without actually finishing the meal? Take Andromeda, our nearest galactic neighbor. Long thought to be a ruthless consumer of dwarf galaxies, new simulations suggest some of its victims might still be orbiting intact, their stars merely redistributed by gravitational turbulence rather than fully absorbed. Even the iconic Magellanic Clouds, once assumed to be on a slow death spiral into the Milky Way, now show trajectories hinting they might survive billions of years longer than predicted. The implications ripple across cosmology. If galactic cannibalism is rarer than we thought, what fuels the growth of giant galaxies? One theory points to quieter mergers, gentler collisions where galaxies blend like swirls in cream, not predator and prey. Another suggests much of a galaxy's heft comes from gas clouds it absorbs, not stars stolen from others. But the most humbling realization: we've been projecting our own metaphors onto the cosmos. Words like cannibalism and violent mergers reflect human narratives, not necessarily cosmic reality. The universe might be less a battlefield and more a dance floor, where galaxies twist and twirl, sometimes brushing close enough to trade stars, but often stepping away unharmed. So the next time you see a galaxy with streams of stars trailing behind it, don't assume it's a monster. It might just be a clumsy partner in an endless celestial waltz, one where the music of gravity plays tricks on our eyes, and first impressions are rarely what they seem. Picture the universe as a spider's web, glistening strands of galaxies stretching across the void, connected by invisible threads of dark matter. This cosmic web, the grand architecture of existence, has been astronomy's blueprint for decades. But what if some of those threads aren't real? Recent studies reveal a startling truth. Not every filament in this web is woven by gravity. Some are mirages, statistical ghosts conjured by the limits of our telescopes and the sheer scale of the cosmos. The illusion begins with how we map the unseen. Dark matter, the universe's hidden scaffolding, doesn't emit light. It betrays its presence only by bending space-time. Astronomers trace its filaments by watching how galaxies cluster along hypothetical lines, like fireflies caught on an unseen net. But here's the catch: when you're dealing with billions of galaxies, random alignments are inevitable. Throw enough dots onto a canvas and some will accidentally form straight lines. The result: false filaments, imaginary bridges between galaxies that seem connected, but are actually light years apart, drifting independently. One notorious example lies in the Pisces-Perseus supercluster. Early maps showed a striking dark matter filament linking two galaxy clusters like a celestial tightrope. But when researchers simulated the region's gravity without assuming invisible threads, the filament persisted. The culprit: perspective. From Earth's vantage point, unrelated galaxies can appear aligned, creating the illusion of structure where none exists. It's like staring at a forest from a distance. Randomly spaced trees can seem to form patterns, only to dissolve into chaos as you step closer. The stakes are higher than just redrawing maps. If some filaments are illusions, our entire understanding of cosmic evolution might be skewed. These threads aren't just decoration, they're the highways along which galaxies travel, funneling matter into the universe's densest hubs. Fake filaments could mean we've misjudged how quickly galaxies cluster, or even how dark matter itself behaves. The solution: a new generation of 3D maps, like those from the Dark Energy Spectroscopic Instrument, are separating fact from fiction by measuring galaxy motions, not just positions. Real filaments pull galaxies toward them, phantom strands don't. Already, these maps have erased dozens of strands once thought fundamental, revealing a cosmic web far more dynamic and mysterious than we imagined. So the next time you see an artist's rendering of the universe's web, remember, some of those threads might be cosmic counterfeit, a trick of perspective in a universe that loves to blur the line between pattern and randomness. The real structure of existence could be even stranger, not a perfect net, but a living, shifting tapestry where some connections are real and others are just the universe's way of keeping us guessing. Neutrinos are the universe's ultimate escape artists, particles so elusive they pass through entire planets like ghosts through walls. But their greatest trick isn't just slipping unnoticed past matter. It's shape-shifting mid-flight, morphing between three different flavors as they race through space at near light speed. One moment, a neutrino is an electron neutrino, born in the heart of the sun. The next, it's a muon neutrino, then a tau neutrino, flickering between identities like a cosmic chameleon. By the time it reaches Earth, its original signature is scrambled, leaving detectors utterly fooled about where it came from or what it truly is. This quantum sleight of hand, called neutrino oscillation, upended physics in the late 20th century. Early solar neutrino experiments detected only a third of the expected particles streaming from the sun. The missing neutrinos weren't gone, they'd simply changed costumes, arriving as flavors our instruments couldn't see. It's like tracking a fugitive who swaps disguises at every border crossing, leaving investigators chasing shadows. The implications are staggering. If neutrinos can disguise their origins, how many deep space particles in our detectors are actually local stowaways, their solar birthplace hidden behind a quantum masquerade? Take the infamous sterile neutrino mystery. For years, certain experiments detected more neutrinos than standard models predicted, hinting at a fourth, even more elusive flavor. But recent studies suggest these anomalies might just be misidentified, oscillating neutrinos, tricks of statistics and detection limits, rather than new physics. The universe, it seems, loves to blur the line between discovery and illusion, especially when subatomic particles are involved. The real magic lies in what this means for astronomy. Neutrinos are cosmic messengers, carrying untouched information from the universe's most violent events: supernova, black hole mergers, even the Big Bang itself. But if their flavors flicker unpredictably, decoding their messages becomes like translating a letter where every third word changes meaning mid-sentence. IceCube, the Antarctic Neutrino Observatory, faces this challenge daily. When a high-energy neutrino streaks through the ice, scientists must work backward, untangling its oscillated state to guess whether it came from a nearby quasar or a distant gamma-ray burst. Sometimes the answer is both. A single particle's path might bend through multiple gravitational fields, its oscillations layered like a Russian nesting doll of quantum uncertainty. What makes this illusion so profound is its humbling lesson. Even the most objective data can be a hall of mirrors. We build billion-dollar detectors to capture nature's truths, only to find the universe whispering its secrets in riddles. Every neutrino that flickers between flavors is a reminder reality at its smallest scales is fluid, deceptive, and far stranger than our instruments can fully grasp. So the next time you hear about a ghost particle from the edge of a black hole, remember, it might just be the sun's light wearing a cosmic disguise. In the depths of the constellation Cassiopeia, a cosmic metronome suddenly fell silent. Pulsar J1846-0258, a spinning neutron star that had ticked with clockwork precision for decades, abruptly stopped its radio pulses in 2006. No slowdown, no sputtering, just dead air. Astronomers checked and rechecked their instruments, convinced something had gone wrong. Then, 580 days later, as mysteriously as it vanished, the signal returned. The pulsar's heartbeat resumed at the exact same rhythm, as if someone had pressed pause on the universe itself. This wasn't just a glitch, it was a violation of everything we know about stellar corpses. Pulsars are nature's most precise timekeepers, ultra-dense neutron stars that beam radiation like lighthouse beams as they spin. Their regularity comes from their immense rotational inertia. Slowing one down should require unimaginable energy. Yet here was J1846, taking a nearly 2-year nap without explanation, then waking up like nothing happened. The leading theory, the star's magnetic field, trillions of times stronger than Earth's, might have temporarily reconfigured itself, creating a barrier that diverted its radio beams away from Earth. Imagine a lighthouse whose light suddenly pivots to shine into the forest instead of the sea. Observers on the coast would see darkness, even though the mechanism never stopped working. But the implications go far beyond one rogue pulsar. If neutron stars can play dead like this, how many other pulsars we've classified as extinct are merely dormant? Surveys estimate there should be hundreds of millions of neutron stars in our galaxy, yet we've detected fewer than 3,000 pulsars. The rest might not be dead, just hiding, their beams temporarily misaligned or suppressed by magnetic sleight of hand. Even more unsettling, some pulsars might switch identities. A few, like the so-called mode-changing pulsars, alternate between different pulse patterns without warning, as if controlled by a cosmic toggle switch we can't see. The deepest mystery lies in what this means for stellar evolution. Neutron stars were supposed to be the predictable end stage of massive stars, dense, stable, and eternal. But J1846's vanishing act suggests they might have active inner lives. With magnetic upheavals we're only beginning to understand. It's like discovering that a corpse you've been monitoring in a morgue occasionally sits up, checks its watch, and lies back down. The universe, it seems, has a dark sense of humor when it comes to rewriting its own rules. So the next time you hear the steady tick of a pulsar's radio signal, remember, even the cosmos's most reliable clocks might be faking their own deaths, waiting for the right moment to remind us that in astronomy, nothing is ever truly as still or as silent as it seems. Deep in the cosmic archives, astronomers have found stars that defy time itself, ancient, flickering giants that should have burned out billions of years ago. These celestial elders glow with a faint, persistent light, their fuel reserves mysteriously replenished like cosmic zombies refusing to die. The explanation might rewrite stellar physics. Some of these stars could be hiding a dark secret at their cores, powered not by nuclear fusion, but by the annihilation of dark matter. The dark star hypothesis turns everything we know about stellar life cycles upside down. Normally, stars shine by fusing hydrogen into helium, a process that eventually exhausts their fuel. But in the early universe, where dark matter was densely concentrated, a different energy source might have ignited. Theoretical models suggest that if enough dark matter particles, hypothetical WIMP or actions, collided and annihilated in a star's core, they could release enough energy to sustain it indefinitely. These dark stars wouldn't just live longer, they'd burn cooler and larger, bloating to sizes dwarfing our solar system while glowing with an eerie, diffuse light easily mistaken for ordinary starlight. The James Webb Space Telescope may have already spotted candidates. In 2023, it detected several bizarre objects in the distant universe, enormous, dim stars with chemical fingerprints unlike anything in modern galaxies. Their light spectra lack the expected heavy elements forged by supernova, as if they've been skipping the usual steps of stellar evolution. Even stranger, some appear in regions where dark matter is thought to cluster, like cosmic lighthouses built atop invisible fault lines. But here's where the illusion gets thorny. Proving a star runs on dark matter isn't like catching a gasoline engine sputtering, it's more like distinguishing two identical candles, one lit by a match and the other by a hidden electrical wire. Both glow the same, but their power sources are worlds apart. The telltale signs would be subtle: an absence of certain fusion byproducts, anomalous temperature distributions, or a gravitational tug stronger than visible matter alone can explain. What makes this idea so revolutionary isn't just the physics. It's the implication that some of the universe's oldest stars might still walk among us, camouflaged as ordinary suns. Imagine a primordial dark star lurking in our galactic backyard, its true nature masked by millennia of stellar drift. If dark stars exist, they'd be cosmic time capsules, preserving the conditions of the early universe in their cores like insects trapped in amber. The hunt for these phantoms is more than academic. If dark stars are real, they'd be the ultimate dark matter detectors, their very existence confirming particles we've spent decades searching for underground. They might even solve a cosmic mystery: why some ancient galaxies appear too bright too early. Dark stars could be the missing link, shining faintly but persistently, bridging the gap between the universe's dark infancy and its luminous present. So the next time you gaze at an unremarkable patch of sky, consider this. Among the familiar twinkles might be a relic from the dawn of time, burning not with fire, but with the invisible fuel of the cosmos itself. The universe's first stars could still be out there, not dead, not gone, just waiting in the dark, their true story hidden behind a veil of borrowed light. Most planets play by the rules orbiting stars, basking in their warmth, tracing predictable paths across the sky. But imagine a world untethered, drifting alone through the eternal night of interstellar space. These rogue planets, flung from their birth systems or formed in the cold isolation of gas clouds, are the universe's ultimate ghost towns, dark, frozen, and nearly invisible. Recent surveys suggest there could be billions of them lurking unseen in our galaxy, outnumbering stars by as much as 20 to 1, the cosmic census we've been taking. It might be missing most of the population. The illusion works like this: when we search for planets, we look for the telltale wobble or dimming of their host stars. But rogue planets have no stars to give them away. Some are detected only by a fleeting phenomenon called microlensing, when their gravity briefly bends the light of a more distant star like a magnifying glass. These events last mere hours, leaving astronomers with barely enough time to confirm what they've seen before the planet vanishes back into the dark. Others emit faint heat signatures, but at just a few degrees above absolute zero, they're often mistaken for dim brown dwarfs or background noise. The result: a shadowy underworld of planets slipping through our nets, quietly rewriting what we thought we knew about planetary formation. Take the case of CFPD Sir 2001-49. Initially catalogued as a brown dwarf, this object wandered alone through space with no star to call home. Later analysis revealed it wasn't a failed star at all, but a rogue gas giant, untethered and adrift. Its surface temperature, a frigid 400 degrees Celsius, colder than Venus yet hotter than Pluto, trapped in a limbo between star and planet, and it's not alone. The Euclid Space Telescope recently spotted a rogue planet just 47 light-years away, floating freely in the Beta Pictoris moving group. At 11 times Jupiter's mass, it blurs the line between planet and cosmic orphan. What makes this cosmic hide and seek so unsettling is the scale of our blindness. If rogue planets truly outnumber stars, then everything from planetary formation models to the odds of life in the universe needs recalibrating. Could some of these wanderers harbor life? It's not impossible. Tidal forces from a gas giant's moons or geothermal heat in rocky rogue worlds might create subsurface oceans sheltered from the cold. And without a star's lethal flares or shifting habitable zones, such environments could remain stable for billions of years, longer than Earth's oceans have existed. The grandest illusion of all, we've spent centuries mapping the heavens assuming planets are the exception, not the rule. But the truth might be the opposite, that for every star lighting up the sky, there are countless dark worlds slipping between them, unseen and uncharted. The universe isn't just a scattering of bright lights, it's a vast, invisible archipelago of lost worlds, waiting for us to acknowledge their shadows. Quasars are the universe's ultimate lighthouses, blazing beacons from the early cosmos, visible across billions of light years. But what if I told you some of these cosmic giants might be playing tricks with time itself? Imagine a quasar flickering like a faulty bulb, its light dimming and flaring not because the engine at its core is sputtering, but because space-time has stretched its signal into a disjointed echo. This is the illusion of time-delayed quasars, where the same object can appear to change centuries apart, all because gravity has tied its light into knots. The phenomenon starts with a quasar's light passing near a massive galaxy or black hole on its way to Earth. Einstein's relativity tells us that heavy objects warp space-time, creating what's essentially a cosmic funhouse mirror. Light taking different paths around this warped space doesn't just bend, it arrives at wildly different times. The result, a single quasar's outburst might reach us as multiple events, stretched over decades or even centuries. It's like watching a fireworks display where each explosion replays years apart, long after the actual show ended. One of the most striking examples is the quasar RX Joan 1131 plus 1231. Observations spanning 2 decades showed its brightness fluctuating in a pattern that defied explanation, until astronomers realized they weren't seeing random flares, but the same flare repeated. The quasar's light had split into multiple beams, each delayed by the gravitational pull of an entire galaxy cluster in its path. The flickering wasn't real, it was an echo, a cosmic tape delay writ large across the universe. Now here's where it gets eerie. If alien astronomers in a distant galaxy were watching Earth through a similar gravitational lens, they might see a disjointed, flickering version of human history. The light from our planet could arrive fractured medieval wars playing out alongside modern skyscrapers, Renaissance art appearing centuries before the pyramids. Entire civilizations might seem to rise and fall out of order, their timelines scrambled by spacetime's funhouse mirrors. This illusion isn't just a curiosity, it challenges how we study the universe's most violent events. When we detect a quasar flaring, how do we know if it's happening now or replaying from the past? The answer lies in untangling the cosmic web between us and the quasar, mapping the invisible mass warping its light. Each delayed photon is a clue, helping astronomers weigh galaxy clusters we can't see directly and even test Einstein's theories at scales no lab could replicate. So the next time you hear about a quasar behaving strangely, remember, the universe has its own editing room, splicing and delaying light like a cosmic filmmaker. And somewhere out there, our own planet's history might be playing back in fragments, a flickering illusion for some distant observer piecing together the puzzle of Earth. Out in the vast catalogue of exoplanets, astronomers sometimes stumble upon what looks like a cosmic twin, a world with a magnetic field nearly identical to Earth's. At first glance, it's thrilling, a protective shield against solar radiation, a potential guardian for alien atmospheres, maybe even a signpost for life. But dig deeper and the illusion cracks wide open. That same magnetic field we celebrate on Earth, on other worlds, it could be a death trap in disguise. Take the case of Kepler 438b, a super-Earth orbiting a volatile red dwarf star. Initial readings showed a robust magnetic field, sparking hopes it might shelter life beneath its glow. Then came the harsh reality: this planet's star doesn't just emit radiation. It erupts in violent flares hundreds of times stronger than anything our sun produces. Instead of deflecting these deadly bursts, the magnetic field funnels them straight to the surface, charging the atmosphere like a cosmic particle accelerator. What should be a shield becomes a lightning rod, supercharging the very radiation it was meant to block. This cruel twist lies in a fundamental difference between Earth's setup and these false twins. Our planet's magnetic field acts like a gentle umbrella, bouncing most solar wind harmlessly into space. But around active stars, especially the turbulent red dwarfs that dominate the galaxy, magnetic fields can tangle with stellar flares in catastrophic ways. The field lines don't repel, they connect, forming invisible highways that channel radiation directly into the atmosphere. It's the difference between holding up a shield and strapping on a target. The illusion doesn't stop there. Some gas giants, like the infamous hot Jupiter HD 209458b, flaunt magnetic fields so powerful they create dazzling auroras visible from light years away. From afar, these shimmering displays scream habitable zone. Up close, the planet's atmosphere is being stripped away atom by atom, its magnetic field accelerating the escape of water vapor and oxygen into space. The very force that makes Earth livable becomes a planetary shredder under different conditions. What makes this cosmic bait and switch so insidious is how it skews our search for life. We're hardwired to seek mirrors of Earth, to assume that what works here must work elsewhere. But the universe loves to subvert expectations. A magnetic field isn't just a blanket, it's a tool, and its effects depend entirely on the hands wielding it. Around a calm sun like ours, it's a guardian. Around a tempestuous star, it's an accomplice to destruction. The lesson: habitability isn't a checklist. It's a delicate dance between a planet, its star, and the invisible forces that bind them. That next Earth-like magnetosphere we spot might not be a sanctuary at all, just another cosmic mirage, beautiful from a distance, brutal up close. The universe doesn't do copies, it does adaptations, and sometimes the most familiar-looking things are the deadliest illusions of all. For decades, we've pictured the solar wind as an unending river, a constant barrage of charged particles streaming from the sun at 1,000,000 miles per hour, shaping planetary magnetic fields and painting the sky with auroras. Then, in 2008, NASA Ulysses spacecraft recorded something that shattered that assumption. The solar wind vanished, not slowed, not weakened, gone. For nearly 2 days, the detectors registered 0 charged particles, as if someone had turned off the sun's magnetic faucet. This wasn't just a quiet spell, it was a cosmic power outage, leaving Earth and other planets momentarily naked against the void. The phenomenon, now called solar silence, reveals just how little we understand about our own star. The solar wind isn't supposed to stop. It's generated by the sun's superheated corona, where temperatures soar to millions of degrees, boiling off electrons and protons in a perpetual outward surge. Yet during these eerie lulls, the corona still glows, its engine running, but its exhaust pipe inexplicably clogged. One theory points to magnetic reconnection, where the sun's field lines snap and rearrange, temporarily sealing off escape routes for particles. Another suggests vast, dead zones in the solar atmosphere, regions where the plasma grows too sluggish to push past the sun's gravity. Whatever the cause, these events are a stark reminder: the sun isn't a machine. It's a chaotic, living system capable of behaviors no model predicted. But the illusions don't end there. Consider the sun's so-called quiet periods. During solar minimum, when sunspots fade and flares grow rare, conventional wisdom says the sun should be calm. Instead, it's often when the most bizarre activity occurs. In 2019, researchers tracking coronal holes gaps in the sun's magnetic field found them spewing ultra-fast solar wind during what should have been a lull. These gusts, clocking over 500 miles per second, defied all expectations, proving that the sun's off switch is anything but. Even stranger are the stealth coronal mass ejections, massive eruptions that leave no visible trace on the sun's surface, silently hurling billion-ton plasma clouds into space. Without the usual warning signs like flares or sunspots, these invisible storms can catch satellites and power grids completely off guard, the most unsettling solar trick of all. Its unpredictability isn't random, it's fractal. Like a coastline that grows more complex the closer you zoom, the sun's behavior follows patterns within patterns, with small-scale eruptions mirroring large ones in ways that fool our forecasting. A seemingly minor sunspot can trigger a disproportionately massive flare, while a dramatic magnetic storm might fizzle into nothing. This isn't just academic, it's a matter of survival. A single unanticipated solar storm could knock out global communications for months, yet our best models still can't reliably predict which disturbances will escalate and which will fade. So the next time you bask in sunlight, remember, that warm glow is the face of a cosmic enigma, a star that defies its own rules as effortlessly as it sustains life. The solar wind might seem constant, but the sun has shown us repeatedly that its rhythms are more improvisation than clockwork. And in those moments of silence, when the solar wind drops to zero, we're left with a humbling truth. Even after centuries of study, our closest star still holds its secrets close, revealing them only when it chooses. Picture the asteroid belt as a cosmic battlefield, rocks colliding, spaceships weaving through deadly debris, danger at every turn. That's the Hollywood version, at least. The reality, NASA probes slip through this so-called danger zone with more empty space than a desert highway at midnight. The average distance between asteroids is over 1 million miles, so vast that if you stood on one, your naked eye might not even spot its nearest neighbor. The illusion of a cluttered, chaotic belt is one of astronomy's greatest misdirections, a myth sold by blockbuster films but busted by cold, hard physics. The numbers don't lie. The entire asteroid belt, all its rocks combined, weighs less than 4% of our moon, spread across a ring wider than the gap between Earth and Mars. That's like scattering a handful of gravel across a football field and calling it an obstacle course. When NASA's Dawn spacecraft visited the belt's largest resident, Ceres, it didn't dodge a single asteroid on approach, not one. Even the famous asteroid fields in Star Wars or Armageddon. Pure fiction. To recreate that density in real life, you'd need to pack millions more asteroids into the belt, enough to block out the sun with their collective mass. But here's where the illusion gets interesting. While the belt itself is mostly void, the few asteroids that do exist tell a violent story. Their surfaces are scarred with craters, not from constant collisions, but from rare, catastrophic hits over billions of years. It's like finding bullet holes in a ghost town, evidence of chaos, but in slow motion. The math is sobering. 2 average-sized asteroids in the main belt might collide once every 10 million years. For context, humanity's entire written history fits into a fraction of that gap. So why does the myth persist? Blame perspective. When we zoom in on asteroid belt images, the rocks seem crowded because we're compressing billions of miles into a single frame. It's like photographing a crowd from a mile away. The people appear shoulder to shoulder, but walk among them and you'll find acres of empty space. Even the famous Kirkwood gaps, regions cleared by Jupiter's gravity, aren't truly empty, just slightly less populated than the rest of the belt. The truth is, the asteroid belt isn't a barrier, it's a museum. Each rock is a fossil from the solar system's birth, untouched by planet-forming forces. Missions like Hayabusa and OSIRIS-REx don't navigate obstacle courses. They embark on cosmic treasure hunts, chasing down needles in a haystack the size of a continent. And the real kicker, the greatest danger to spacecraft in the belt isn't asteroids, it's loneliness. With so much nothingness between targets, a single missed calculation could send a probe drifting forever without another rock to visit. The lesson here goes beyond astronomy. It's about how easily Hollywood's fantasies overwrite reality in our minds. We've been conditioned to see chaos where there's mostly calm, to imagine celestial traffic jams in what's really a cosmic ghost town. The next time you watch a spaceship ducking asteroids on screen, smile, then remember the silent, spacious truth. The universe doesn't do crowded. It does vast, quiet, and beautifully empty, with just enough rocks left over to keep the dreamers guessing. In the afterglow of the Big Bang, the cosmos left behind a thermal fingerprint, the cosmic microwave background, a near-uniform blanket of radiation stretching across the entire sky. But there's a glitch in this celestial snapshot, a chilling anomaly known as the cold spot, a region of space noticeably cooler than its surroundings. At first glance, it might seem like a minor imperfection, a cosmic wrinkle, but this icy patch, spanning nearly 1 billion light-years, could be the universe's most tantalizing mystery or its most deceptive illusion. The leading explanation, a supervoid, an unfathomably vast emptiness where galaxies are eerily scarce. In such a void, photons traveling through it would lose energy as the universe expands, cooling the light we detect. But here's the problem, the cold spot is too cold, too large. Even the most extreme voids we've mapped don't fully account for the temperature drop. It's like finding a freezer in the middle of a desert with no power source. Something doesn't add up. That's where things get surreal. Some theorists propose the cold spot isn't just a void, it's a bruise. A cosmic collision mark left by a parallel universe brushing against ours in the multiverse's earliest moments. In this scenario, our universe's inflation, the rapid expansion after the Big Bang, might have been interrupted by a neighboring bubble universe, leaving behind a gravitational imprint that cooled the background radiation in that spot. It's a radical idea, one that turns the cold spot from a curiosity into potential proof of realities beyond our own. Yet skepticism lingers. Alternative explanations range from statistical flukes, a random cold patch in an otherwise uniform sky, to exotic physics, like a cosmic texture defect, a glitch in space-time structure left over from the universe's birth. Even the supervoid theory isn't dead. Recent surveys suggest there might be overlapping voids, each amplifying the cooling effect beyond what we'd expect from a single empty region. The cold spot's true nature remains one of cosmology's great debates. Is it a flaw in our models, a sign of unseen physics, or a window into the multiverse? Every new observation deepens the mystery. The Planck satellite's meticulous maps confirmed its existence but couldn't settle its origin. Future telescopes, like the European Space Agency's Euclid, might finally weigh in either by finding hidden structures or leaving us with even more perplexing questions. What makes this illusion so compelling isn't just the science, it's the philosophical whiplash. A cold patch on a map could rewrite our understanding of reality, forcing us to confront the possibility that our universe isn't alone. Or it could be a cosmic red herring, a reminder that even the most precise measurements sometimes lead us down rabbit holes. Either way, the cold spot stands as a humbling testament. The universe loves to hide its secrets in the smallest details, waiting for us to look closer, think deeper, and question everything we think we know. A star streaks across the galaxy at 1,000 kilometers per second, fast enough to cross the distance from Earth to the Moon in just 6 minutes. Conventional wisdom says such hypervelocity stars must be the victims of supermassive black holes, slingshotted into oblivion by gravitational forces too extreme to resist. But the cosmos has a way of upending our assumptions. Some of these stellar speedsters aren't running from black holes at all. They're the survivors of supernova explosions so violent they function like cosmic cannons, firing their surviving siblings into the void with unimaginable force. Take the case of LP 40-785. Racing through the Milky Way at over 600 kilometers per second, this rogue star was long assumed to be a black hole's handiwork, a celestial bullet fired from the galactic center. Then astronomers traced its path backward, and the story unraveled. Rather than originating near Sagittarius, a star, our galaxy's central black hole, this star's trajectory pointed to a quiet patch of the Orion Arm. The smoking gun, a neutron star moving in perfect tandem, the telltale remnant of a supernova that once bound these two together in a binary system. When the more massive star exploded, the surviving partner was flung outward like a stone from a sling, carrying the energy of the blast as kinetic fury. This discovery cracks open a cosmic whodunit. Until recently, every hypervelocity star was presumed to be a black hole escapee. Now we know supernova can launch stars with comparable ferocity, their shockwaves calibrated to near-perfect symmetry to achieve such incredible speeds. The illusion lies in the assumption that velocity equals origin. That speed alone can tell us a star's backstory. In reality, nature has multiple ways to fling stars into the abyss, each leaving similar fingerprints. It's like finding identical tire tracks at two crime scenes, one from a sports car, the other from a motorcycle. Without context, you'd never guess they came from entirely different machines. The implications ripple across astronomy. If supernova can produce hypervelocity stars, then the outer reaches of our galaxy, and even intergalactic space, might be littered with these castaways, their origins obscured by time and distance. Some could be ancient travelers, fired into the void by explosions that predate our solar system. Others might be newcomers, their parent supernova still visible in distant galaxies. The challenge: telling them apart. Black hole ejections leave distinct chemical signatures, stars stripped of outer layers by tidal forces, while supernova survivors often carry traces of their explosive birth in their atmospheric composition. But here's where the cosmic trickery deepens. Some hypervelocity stars show traits of both. Gaia BH1, for example, moves like a black hole escapee but carries elemental abundances suggesting a supernova's touch. The truth might be messier than we thought, a stellar tag team where black holes and supernova work in tandem, their combined forces launching stars at speeds neither could achieve alone. Imagine a cannonball fired from a moving train. The velocity stacks, creating projectiles fast enough to escape not just galaxies, but entire galaxy clusters. The lesson here transcends stellar mechanics. It's a reminder that in astronomy, first impressions are often mirages. What looks like a single phenomenon, stars moving impossibly fast, turns out to be multiple processes wearing the same disguise. The universe doesn't care about our categories. It's a laboratory of infinite variety, where the same effect can spring from wildly different causes, and where every rule has exceptions waiting to be discovered. So the next time you hear about a star breaking speed records, don't assume you know its story. The cosmos loves a good plot twist, and hypervelocity stars are its favorite thrillers. The universe was born with a cosmic ledger that should have balanced to 0 equal parts matter and antimatter, destined to collide and annihilate in a flash of pure energy. Yet here we are, made of the leftover crumbs from that near-perfect symmetry. This isn't just a lucky break, it's the ultimate sleight of hand, a fundamental imbalance so precise that even the most advanced particle colliders can't fully explain it. For every billion particles of matter created in the Big Bang, one survived the antimatter purge. The rest obliterated in the first microseconds of existence, leaving behind a ghostly whisper of radiation and us. Dig into this illusion and the mystery only deepens. Particle physics insists matter and antimatter are nearly identical twins, mirror images obeying the same rules. When they meet, they should vanish without a trace, but some subtle cosmic cheat tipped the scales. The Large Hadron Collider has spotted fleeting hints of this betrayal, particles called mesons decaying slightly differently than their antimatter counterparts. The difference is vanishingly small, less than 1%, but in the furnace of the early universe, that fractional imbalance was enough to spare a sliver of matter from annihilation. It's like rolling a billion dice and having just one land on an edge instead of a face, a statistical miracle woven into the fabric of reality. The plot thickens when you consider where all the antimatter went. Theory says it should still exist in vast clouds somewhere, yet searches turn up empty. Balloon-borne detectors over Antarctica, satellite surveys of gamma rays, all come back negative. The most tantalizing clue: certain high-energy cosmic rays hit Earth's atmosphere with signatures suggesting they might be antihelium nuclei, potential relics from antimatter domains hiding in the cosmic voids. But these detections are so rare, so controversial, they might as well be cosmic will-o'-the-wisps, teasing us with the possibility of entire antistars or antigalaxies lurking just beyond our telescope's reach. What makes this asymmetry so unsettling is how it defies the very laws we thought governed existence. The universe loves symmetry. Electrons have positrons, protons have antiprotons, yet at the grandest scale, the books don't balance. Some theorists propose undiscovered particles, heavier versions of neutrinos that decayed unevenly in the early cosmos. Others speculate about parallel antimatter universes, separated from ours by an impassable barrier at the Big Bang. The wildest idea, that antimatter isn't missing at all, it's hiding in plain sight, woven into dark matter's invisible web. This isn't just academic curiosity. That 1 in a billion asymmetry didn't just spare atoms. It shaped galaxies, stars, and eventually the chemistry of life. Tweak the numbers slightly, and the universe could have been a featureless void or a seething mass of radiation. The fact that we're here to ponder this at all is the universe's greatest magic trick, a vanishing act so perfect it left behind everything we know. And the encore, the lingering suspicion that somewhere, in some form, antimatter is still out there waiting for its curtain call. Behind every cosmic illusion lies a truth more valuable than the illusion itself, a crack in our understanding where new light pours through. Think about gravitational lensing, that celestial sleight of hand where galaxies bend light like a funhouse mirror. At first glance, it's just a pretty distortion. But peer deeper, and you'll find it's the universe's own scale, weighing dark matter we can't see by how it warps what we can. Those phantom galaxies and duplicated quasars aren't just optical oddities, they're proof that 95% of the cosmos is invisible, nudging us to build detectors sensitive enough to catch shadows. Consider the pulsar that vanished for 580 days, defying every textbook on stellar behavior. Its silence wasn't a glitch, it was a dare. Astrophysicists had to invent new models of magnetic field dynamics just to explain how a neutron star could play dead, rewriting chapters on stellar evolution in the process. Even failed illusions matter. The diamond planet that turned out to be a lava-shrouded inferno. It taught us that extreme pressures don't always create gems. Sometimes they forge nightmares, forcing us to reconsider how carbon behaves under conditions no lab can replicate. These cosmic tricks do more than dazzle. They expose the limits of our tools and the biases in our thinking. For centuries, we assumed rogue planets were rare until improved infrared sensors revealed billions adrift in the dark, proving our solar system's tidy architecture is the exception, not the rule. The cold spot in the cosmic microwave background, whether it's a supervoid or a bruise from a parallel universe, reminds us that even our most precise maps might be missing whole layers of reality. The greatest lesson: illusions are the universe's way of keeping us honest. Every time we think we've decoded its patterns, whether it's the orderly spin of Jupiter's poles or the predictable pulse of a quasar, the cosmos throws a curveball. Those curveballs aren't taunts, they're invitations to build better telescopes, to question old assumptions, to stay comfortable with not knowing. After all, the day we stop being fooled is the day we stop discovering. The magic isn't in the trick, it's in the revelation waiting just behind the curtain, where every misdirection points to a truth we're only beginning to grasp. From phantom supernovas replaying their final acts across cosmic time to diamond planets that turned out to be molten deceptions, the universe has proven itself the ultimate magician, not just hiding its secrets, but dazzling us with misdirection. These illusions aren't flaws in the cosmic canvas, they're brushstrokes revealing a deeper masterpiece. Take gravitational lensing. What first appeared as duplicate galaxies turned out to be spacetime's way of sketching dark matter's invisible hand. Or consider rogue planets, once dismissed as astronomical flukes, now rewriting the rules of planetary formation. Every cosmic trick carries a revelation tucked inside its deception, waiting for the curious to unravel it. The beauty of these celestial sleights of hand lies in their duality. They humble us, showing how even our sharpest telescopes and brightest minds can be fooled, while simultaneously empowering discovery. When a pulsar winks out for 580 days, or a quasar's light splinters into fractured echoes, it's not just nature playing games. It's an invitation to dig deeper, to question assumptions we didn't even realize we'd made. The cold spot in the cosmic microwave background might be a statistical fluke, a supervoid, or something far stranger, a fingerprint from beyond our universe. The uncertainty itself is a gift, a reminder that the cosmos reserves its greatest rewards for those willing to sit with the unknown. What's next? As telescopes like James Webb and Euclid peer further into the abyss, we'll undoubtedly uncover fresh illusions. Maybe we'll find dark stars burning with the ashes of ancient particles, or catch a galaxy in the act of pretending to be older than the universe itself. Each new mystery will demand sharper tools, bolder theories, and the courage to admit when our old maps no longer match the terrain. The history of astronomy is littered with facts that turned out to be mirages, proof that the universe's favorite language isn't answers but better questions. So the next time you stand under a starry sky, remember, every twinkle up there could be a lie. A star that died millennia ago, a planet that isn't a planet, or a black hole wearing a neutron star's disguise. But that's the thrill of it. Reality isn't just stranger than we imagine, it's stranger than we can imagine, revealing itself one illusion at a time. If this journey through the cosmos' greatest tricks left you awestruck, don't keep it to yourself. Smash that like button, subscribe for more deep dives into the universe's playbook, and drop your favorite cosmic con in the comments. The grandest deceptions are still out there, waiting for someone to look closely enough and call the universe's bluff.